Hey, it's Sukrit from STEM Coder, and today we're going to take a look at the power rule. We know that the derivative of x is equal to 1, and that can be written as 1 times x to the power of 0. We also know that the derivative with respect to x of x squared is equal to 2x, which can be written as 2 times x to the power of 1. Well, what's the derivative of x cubed with respect to x? Let's take a look. We can break up x cubed as x times x squared, and we can apply the product rule to find the derivative. So it's going to be the x times the derivative of x squared plus the derivative of x times x squared, and that gives us 3x squared. What is that? 3x squared, which is equal to 3 times x to the power of 2. Do you notice the pattern over here? We got 1 times x to the 0, 2 times x to the 1, 3 times x to the power of 2. Can you try guessing the power rule? Well, here it is. X to the power of n, so derivative of this with respect to x, is equal to n times x to the power of n minus 1. That's the power rule right over here. And this works for any value of n. So what's the derivative of x to the power of 5? Well, that's equal to 5x to the power of 4. Well, what's the derivative of x to the power of negative 3 with respect to x? Well, that's equal to negative 3x to the negative 4. Well, this is negative 3 minus 1, so that gives us negative 4. And what about the derivative with respect to x of x to the power of 1.5? Well, that's equal to 1.5 x to the power of 0.5. If you have a whole number exponent, or at least a positive integer exponent, you can generally simplify this power rule to the product rule. But if you have a non-whole number exponent, like 0.5 for example, proving the power rule is slightly complicated. Not too bad, but nevertheless beyond the scope of this lesson at least. We will be looking at it in future videos, but for now, just make sure you understand this power rule. The derivative of x to the power of n is equal to n times x to the power of n minus 1.